Hello, my dear viewers. This is the fifth part of the class 12 the physics chapter 1 regarding the charges. Now, here in this part, I am going to discuss the electrical field due to a dipole at any point on the equatorial line. That means in the previous part, I have explained to you along the axial line. No, there will be a electric field intensity, and we have calculated that, which will be equal to E is equal to 1 by 4 pi epsilon 0 into 2p by r cube at last, no, by a special case. But here only half the value is found out. Really what is happening is that these two interferences will make what is in the middle, no, to be less, but these two will get more interference when it is placed to this point. If it is in the axial line, more interference, so that the electric field intensity in the axial line will be double that of the equatorial position. So that is the essence of the whole thing. So we will start how it is calculated. The electric field intensity due to a dipole. This is the dipole. Electric field intensity is to be found at any point on the equatorial line. What is equatorial line? Earlier, Earth, when we take, there is an equator now. That means a middle part line. So this dipole is containing a middle part now. This is the part, and that line which passes through that middle part, but perpendicular to the axis of that dipole. Okay, so by telling equatorial line is perpendicular to the axial line, joining the charges and cuts the dipole length into two equal parts. That is, 2a is divided into two parts. And then comes the resolution things. I will brush up the whole thing which is to be understood. That is, this is y-axis, na. This is x-axis, na. But to be understood in mind that if a force, makes an angle with the x-axis theta, and again by the remaining will be 90 minus theta over here, no, then just you understand that if it makes a theta angle with the x-axis, a force, no, then we resolve that into two components. That is a horizontal component and a vertical component. The horizontal is like this. Okay, horizontal component, and the vertical component is vertical. Okay, it is laying is horizontal and vertical is vertical component. Then the vertical component is f sine theta and horizontal component is f cos theta. Just remember that the force when resolved into two parts, that is horizontal component and vertical component. The horizontal component means f cos theta. The theta is making with the x-axis, and then that sine theta is the vertical component. This will be useful in solving all these things, derivations. Okay, so I have explained to you this minus q charge is placed over here position B, plus q charge is placed over position A. In between there is a middle point which cuts this whole length into two equal parts, and then comes a point in the equatorial position through which a field line passes from the q over here, and a field line passes towards minus q from here. Okay, this is denoted by this due to the minus charge, it is denoted by E2. Due to the plus charge, it is denoted by E1. Okay, so the angle with which this with which this occurs, it is denoted by theta. Okay, this is the thing. Okay, this is, let a line which is parallel to horizontal, this dipole is drawn from P towards left. Okay, then an angle is formed, a theta angle is formed. Okay, then that this angle will be equal to this angle now. Okay, understand this. If these two lines are parallel, the straight angles here, this angle and this angle will be equal. So this theta is considered over here, and another angle is that theta is another angle which is divided also. This theta is same as this theta. Okay, so understand the thing is that a angle theta is selected over here and another angle theta is selected over here. These two are equal angles. Okay, and then a field intensity line which is starting from Q and emitting out through the P is noted E1, and a field intensity which is from P towards Q, because the field lines are towards minus sign, no, perpendicularly towards it. So E2, and what is another nomenclature? The distance from the middle point to the P, no, the distance is R. Okay, not that. Then the distance of PA and PB is to be X, noted. Okay, then just by what I have taught you right now, thing is that we can take this angle now, this E1. Then what is its vertical component of this? This is E1 sin theta. This is the vertical component, and this is E1 cos theta is the horizontal component. Okay. Then what will be the next thing? This theta, which is towards this, the E2 component towards this minus sign. No, this electrical field intensity E2, which is towards this negative charge. No, so that makes an angle. Let it be, this be the horizontal line, and this is the angle which it makes. Okay, so this is the horizontal line. Then the angle with which it makes the horizontal component will be E2 cos theta is this. Okay, so E1 cos theta same along the same line itself, E2 cos theta comes. Okay, E2 cos theta. Okay, and what will be the sin theta? This thing. It will go this. It will go this way. So this E2, which is taken, this vertical component is in this direction, so it will come over here. E2 sin theta. Okay, so the angle which is the PB angle, no, the E2 which is making angle with this thing, which can be resolved into horizontal component like E2 cos theta and vertical component like E2 sin theta. Okay, after all that, we will eliminate these E2 sin theta and E1 sin theta are opposite direction, no, so they are equal and they will cancel each other. And this E1 cos theta and E2 cos theta in the same direction, no, they will add up each other. Okay, so diagram is complete, but we want to explain it much better and to find out what is the whole relation. What is to be found out? That means the electrical field due to dipole at any point on the equatorial line. We want to find out this. So here E1 and E2 gets cancelled out. So vertical component cannot be taken because this will cancel out. But one thing is that the total resultant will be E1 cos theta plus E2 cos theta. You find out. So to make convincing to the examiner, no, just write intensity of electrical field at P. Intensity of electrical field at P due to plus charge Q is equal to force on the unit positive charge placed at P. That's the basis, no. We were the force on unit positive charge. So Q into 1 coulomb, that is Q coulomb itself. That is E1 is equal to 1 by 4 by epsilon 0 into Q by x square. That is along AP direction, that is emanating from this positive towards outside. So in the direction AP. And intensity of electric field at P due to this minus Q is 1 by 4 by epsilon 0. E2 is equal to 1 by 4 by epsilon 0 Q by Q, the charge Q by Q, this Q charge by what is the distance? X square, this square, distance square, along PB. That means it is towards this minus charge. So PB, and earlier AP outside, and here towards minus Q. Now any field line will come towards it. So along PB. And then you want to write a sentence, since E1 and E2 are inclined at an angle 2 theta. This is a E1 and E2. This E1 and E2 are inclined at an angle 2 theta. This angle can be divided into, resolved into horizontal and vertical component. The vertical component is E1 sin theta. This thing, this E1 is resolved into E1 sin theta and E1 cos theta. And then this E1 and E2 sin theta here, which I have said earlier regarding this E2 sin theta and E1 sin theta. These two get equal and opposite and they get cancelled out. And horizontal component E1 cos theta and E2 cos theta will only be used and they will get added up. So what will be remaining? The resultant intensity of electric field at P. Here This 2 will get cancelled out, and what will be remaining? E1 cos theta plus E2 cos theta. Just write that. That is the only thing which we got to solve this problem. So we got E is equal to E1 cos theta in the same direction, E2 sin theta. Just add up. Since E1 and E2 are equivalent in magnitude, okay, E1 and E2 are equal. So just put E1 value for E2 itself. Here, no, put E1 itself. They are equal, no? So E1 cos theta plus E1 cos theta. That is 2 E1 cos theta. That's it. Then E1 value we know na earlier. What is that? E1 is equal to 1 by 4 pi epsilon 0 q by x square. You put over here. This 2 is there and put the value of E1 and then cos theta. Okay. And then cos theta, you find out cos theta is what? What is cos theta? Then this cos theta will come like this. That means here cos theta, let the angle be theta over here. Okay, same angle theta. Then what will be cos theta? The cos theta will be adjacent side by hypotenuse. Okay, that means a by x, which is written over here. Okay, cos theta. Then understand this is the angle. Okay, cos theta a by x. And then that a by x is written over here. Cos theta is equal to adjacent side by this. This is the theta angle under consideration. So a by x is the angle, and then cos theta is replaced by a by x. All remains the same. And then we want to form like this. E is equal to 1 by 4 pi epsilon 0 2a into q. Okay, that means no. Here 2a is the distance. 2a is the distance between these two, no? And q is there, no? That means let it be there for time's sake. And then x square into x cube. This 2a into q can be replaced by the dipole moment. You know, earlier, what is dipole moment? The charge into distance between these two charges. Okay. Okay, either of the charges into distance. That is, okay, not by p. And x cube, no, we want to write in another way. X cube, we do not know what is really x cube, but we do in the terms of r square and a square. Now, consider this as a right triangle. Okay, then x square is equal to r square plus altitude square plus base square. That's written. Then x is equal to root of r square plus a square. Then root can be written 1 by 2 form. And when the whole is cubed, no, that means x cube is equal to r square plus a square, the raised to 3 by 2. Okay, a raised to mn. That form. Theory of indices law. Okay, 3 by 2. The same thing we take it out and placed in here. X cube value is placed over here. This is the equation. Yet the electric field due to a dipole at any point on the equatorial line. This is the equation to be noted. But a special case is there. So your examiner will give full marks only if we write about the special case also. The special case includes when this dipole length will be very small. Okay, so this very small length is this small length will get to an infinitesimal value. That means very small value. That means a is equal to 0. That I have put over here. Epsilon, the intensity, electric field intensity is equal to 1 by 4 pi epsilon 0 p by r square plus 0 square. Oh, this is insignificant. No, there is no need. So r square raised to 3 by 2. That is written over here. So 2 and 2 gets cancelled out. Okay, a raised to mn law, theory of indices. So r cube will remain. Hey, look at this. I will similarize it with the earlier what we found in the axial problem. Now, along the axial line, the electric field intensity will be 2p by r cube. Now, here it is half only. So, we understood that this electric field due to a dipole at any point on the equatorial line is half that value of electric field intensity to a dipole at the axial line value. This is enough here. So even if I have put this, I need your support. Please like, share, subscribe my channel. Be happy, be cool, yeah. I'll be back with the part 6.